Hello and welcome to this video on memory allocation in data structures. In this video, we will explore how data structures allocate memory to store data and the different types of memory allocation methods used in data structures. Data structures are essential tools for organizing and manipulating data in computer programs. However, every data structure requires memory to store its data in a specific format. For example, a stack data structure may need to allocate memory for each element pushed onto the stack. In general, there are two categories of memory allocation methods used in data structures: contiguous and linked memory. Contiguous memory allocation refers to the approach where a data structure allocates a single block of memory for storing all its elements. This is often used in arrays and matrices, where each element is stored in consecutive memory location. Contiguous memory allocation enables fast access to data, as the position of each element can be calculated using simple arithmetic operations. Linked memory allocation, on the other hand, involves allocating multiple blocks of memory and linking them together using pointers. This method is used in linked lists, trees, and graphs, where the connections between elements are not fixed in a contiguous block of memory. Linked memory allocation provides more flexible in storing and manipulating data structures, as elements can be added, removed, and reordered dynamically. In addition, there are different ways of managing memory allocation in data structures, such as static and dynamic allocation. Static allocation means that the memory is allocated at compile time and does not change during the program's execution. This is often used in simple data structures where the size and data are known in advance. Whereas dynamic allocation, on the other hand, means that the memory is allocated at runtime and can be resized and reallocated as needed. This is often used in more complex data structures or when the amount of data is not known in advance. Memory allocation is a fundamental aspect of data structures that determines how data is stored and accessed. By understanding the different types of memory allocating methods and techniques, we can design and implement efficient data structures that meet the requirements of our program.